Welcome, kiddos, to the last portion of our gravimetric stoichiometry. Remember, gravimetric stoichiometry is dealing solely with moles and mass. Today, we're going to be looking at mass to mass. We've already talked about how to go from moles to moles, moles to mass, and mass to moles. Now we're going to go over mass to mass, which is the more complicated one. It's not harder, it's just a little bit more complicated because there's an extra step. I'm also going to show you different strategies. I'll talk about my least favorite strategy and my favorite strategy. So let's recap and talk a little bit about what stoichiometry is. It's a method of problem solving where we're taking known quantities of one substance, right, to find unknown quantities. Now, here's the difference of a different entity, another entity. So it's a different one. We're not just going from one substance to the one substance. We're going from one substance, it could be in the reactants, to find a totally different substance. And remember, we use the molar ratio to find that. It always requires a balanced equation. There's always a series of steps to go from moles to the molar ratio back to whatever we're looking for. And it always involves a mole ratio to switch substances. The mole ratio is the thing that allows you to go from one substance to another substance. Very important. And of course, you have to have your equation balanced correctly in order to do that. Writing chemical equations, net ionic equations, and dissociation equations is essential. That we're going to learn later on. So this is not to worry. This is just an example, some foreshadowing of what's happening right away. We need to know how to convert grams to moles and moles to grams. So in saying that, we're going to take a look at some gravimetric stoich examples where we're looking at mass. We're going to use gravimetric stoichiometry. We can apply our knowledge of balanced chemical equations and our mass to mole conversions to predict the mass of a product, and to estimate the amount of reactant we need to, for the reaction to produce a certain product of mass. Okay, cool. So let's take a look at the steps. Step number one, we write a balanced chemical equation. We're going to list the measured mass given the unknown quantity required and the conversion using molar mass. It's very important that we populate our balanced equation. I'll show you an example of how to do that. We're going to convert the mass of the measured substances to the moles of the measured substances. And we're going to use our molar ratio. This is the most important part of stoich, as you know. When we're using our molar ratio, we're using our coefficients of the balanced equation. On the numerator, the top part, we're always looking at what we're looking for, and the bottom portion on the denominator, what we are given, what we know. What we know and what we don't know, what we're trying to find. Okay, this is what we're trying to find. This is where our question is, what we're trying to find. So in essence, right now, we're going from mass, converting mass to moles. We'll use the molar mass to do that. And then we go into our molar ratio, right? On the top, we're looking at what we're looking to find and what we know on the denominator. And then we convert back to mass. And remember, for conversions from mass to moles and moles to mass, we need our molar mass in order to do that. So here's our first example. How many grams of oxygen are required? How many grams of oxygen are required to burn 10 grams of propane? This is my least favorite strategy because it chunks everything, and at first it seems like a good idea, but as you move on, you'll notice that it's kind of annoying. So the first step we're going to do, so step number one, actually this is step number one, this would be step number two. We're going to find the number of moles of propane, we're going to convert mass to moles. So we have 10 grams, right? Because it's giving you 10 grams here of propane. Use my molar mass of propane to get moles of propane. This is moles of propane. Grams cancel out. Now what we do is we find our answer. So here's our moles of propane. And we use our molar ratio. We're comparing propane to oxygen, right? This is what we have. propane, and this is what we're looking for. Which is oxygen, and that's where the 5 comes from. So then our next step, because now here we have moles of O2. Now we have to go from moles of O2 to mass of O2. So here we have our moles of O2. Don't use rounded answers. You have to use your full answer. Now here's our molar mass of oxygen, and we just make sure that the moles cancel out to get our answer in grams. So this took quite a bit of real estate in order to answer a question. So that's why it's not my most favorite. So here's another example using a different strategy. We're going to write our balanced equation. And then what we're going to do, this is really important, is we are going to populate the balanced equation. So we have 20 grams of butane. So here's my butane, here's my 20 grams. This is what's given. Right away, because I have my mass here, I'm going to use my molar mass. I'm going to write it down right away. Here's my molar mass of propane. And then we also identify what we're looking for and the molar mass, because we are looking for how many grams of carbon dioxide. And here's our molar mass of carbon dioxide. Okay, now that everything's populated, it's much easier to set the question up. So let's just go on and go ahead and show you everything that you need. So this is what you start. You always start your equation with what you are given. Now I'm going to go from grams to moles by looking at using my molar mass. My grams cancel out. Now this is what I have. Notice that it's written down. This is my favorite way because it actually identifies what you have and also identifies what you're looking for. I'm looking for carbon dioxide, and the coefficient for carbon dioxide is 8. And the coefficient for what I have is 2, which is butane. So now all I have to do is this molar ratio gives it goes from moles of butane to moles of carbon dioxide, and then I use my molar mass of carbon dioxide to cancel out my moles of carbon dioxide to my mass of carbon dioxide. And there's my answer, kiddos. Okay, in a case like this, what mass of iron 3 oxide is required to produce 100 grams of iron? When you don't really know what the heck is going on, they always give you a balanced chemical equation. So here's my balanced chemical equation. It's given to you because you don't know it's reacting with carbon monoxide, and it doesn't say that in the question. So in a case like this, you're going to get a balanced equation. So now what I'm going to do is I'm going to populate. I'm going to identify what I'm looking for. I'm looking for the mass of iron 3 oxide, right? That's what I'm looking for. And you are given 100 grams of iron. So there's my 100 grams of iron. Here's my molar mass of iron. And here's my molar mass of iron 3 oxide. Okay? So now I start. This is what I'm looking for. To identify what you're looking for. So I'm starting with my 100 grams, and I always start with what this is like everything I need, so of course I start there. I have my molar mass of my iron, my grams cancel out, and then I get my moles of iron. Now here, it's just giving you the molar ratio. It's not identifying what the substances are, so this could be very tricky, this part here. Just make sure this is of what you have, so that's where the 2 comes here from, and the 1 is what you're looking for. And there's a 1 there. And this is going to give me my moles of what I'm looking for, which is my iron 3 oxide. And there's my molar mass of iron 3 oxide, because then my moles cancel out to get my mass of iron 3 oxide. So remember to keep unrounded values in your calculator for further calculation until the final answer is reported. Please complete the questions found at the end of the notes package. I will post the key by the end of the day. Hope you guys have a great day, and I'm also going to post a formative assessment. It's formative, but I will be checking who completes it so I can show in your Power School who has completed it. And the next day we'll go on to percent yield. So just relax, go through this, do some practice questions, and like I said, I'll post the key by the end of the day.